എൻ്റെ ശീലത്തെ നാവിലാകേണമേ സ്നേഹമാകുന്ന ഗീതമോ എൻ്റെ കാതിനിണയാകണേ സത്യമെന്നുള്ള ശീലമോടെ ഞാൻ ശാന്തി അറിയണമേ ഭൂമിയമ്മയെന്നറിയുവാനുള്ള ബോധമുണ്ടാക്കണേ ജീവജാലങ്ങളാകെയും ജന്മബന്ധുവായിടണേ ജാതിഭേദങ്ങളെന്ന ശാപമോ ദൂരമറയണമേ ലോകമൊന്നിന്ന് പാഠമെന്നുമെൻ മനസ്സിലെഴുതേണമേ
ആചാര്യാനുസ്മരണം.
രശ്മിയുടെ കണക്ഷൻ പോയോ?
Reshmi?
Sir.
Sorry, Reshma? Yeah.
Then I would like to welcome Mr. Sadish R., Convener, Department of Physics, for the welcome speech.
A warm good afternoon to everyone who are gathered in this Google Meet, except the resource person, towards the international webinar on supercapacitors organized by Department of Physics in association with IQAC and Science Club, VTM NSS College. I said except the resource person because he is having a good morning rather than good afternoon. Hi, good evening. Okay. I said because today we had a morning session on ozone day. We know that today is an international day for preservation of ozone layer, and we made plans to have an international webinar. And looking through the topics, we found supercapacitors as one of the emerging topic in this area, and we found an expert person and a friend of mine, luckily, for this role. Coming to my role is to deliver the welcome address. First, I have to welcome Dr. Bijini B.R., HOD, Department of Physics, VTM NSS College, who will provide the welcome address and who will provide the presidential address and preside over the function. She always encourages for such kind of activities, and thank you, ma'am, and welcome on behalf of the seminar. And me. Next, it is our head of the institution, Dr. Anand Kumar VM, who does the administrative role, I believe, because he provides us the opportunity to explore in such avenues, and he supports us to organize such seminars. Thank you, sir, for all your support, and welcome you, sir, on behalf of the Department of Physics and the seminar itself. Next, I have to welcome the chief guest or the resource person, who is my friend, Dr. Ibu Manyakal from University of Glasgow, UK. And as I said previously, the seminar was fixed at an earlier time, but for that he has to get up very early. Luckily, since he is a busy person, he has 2 meetings today itself, And in between the two meetings, he has found time to engage us with the research finding, and his research topic could be disclosed to the Indian community. Thank you, Libu, for accepting my invitation and providing us this time and engaging us through this session. I welcome you, Libu, to the session. Next, I have to welcome. Thank you. Next, I have to welcome our IQAC coordinator. There's no words to define her because she is the governance of this seminar. Because you can see my profile as IQAC because all the feedback, all the certificates are going through this link, and she has taken all the pains to prepare it. That is why maybe IQAC has to do, so it is not mandatory that IQAC has to perform all these functions, but she does more than what she gets, the credit she gets. Thank you, ma'am, and I, on the behalf of this seminar and Department of Physics, would welcome you to the session. Next is the seminar is also jointly organized by Science Club. Miss Manju is handing the convener of this Science Club. She is always processing of conducting activities. She came to me whether she has to prepare a certificate or template for such. I told no problem. Your support is enough. And I also welcome Miss Manju to the international seminar on behalf of the department and the webinar itself. Welcome, ma'am. Finally, I have to welcome all the teachers of the department, Dr. Praveen, who's delivering us the vote of thanks, and Dr. Deebavi, who also works with me, and all the teachers of VTM NSS College who are attending this seminar. And there are students of other institute and teachers of other institute, research scholars of other institute who are eagerly listening to this seminar. Welcome you all to this on behalf of Department of Physics and the college. And finally, it is our students, our S1 and S5 students, kindly listen to us talk eagerly and get fruitful ideas from them. Welcome you all. Thank you.
Thank you, sir. Now it is the time for presidential address. I would like to invite Dr. Bijini BR, HOD of Physics Department.
Respected Principal Dr. VM Anand Kumar sir, our resource persons Dr. Libu Manjikal, IQAC convener Shyama Pillai, Science Club convener is Manju MJ, Program Coordinator Sadish R, our faculty members Dr. BN Praveen, Dr. Deebavi, other faculty members from our colleges and faculty members from other colleges and research scholars from other colleges and my dear students. Now we are here for the second program of Ozone Day celebrations 2020 conducted by our own department. International webinar on the topic Supercapacitor. In the morning forenoon session, in the social awareness program, we have a presentation by Jwala Nandini, and she discussed the effect of excessive use of petroleum products on automobiles, which causes the emission of nitrous oxide and its effect on the depletion of ozone layer. And to reduce such an emission of ozone layer due to the to protect our ozone layer due to the emission of nitrous oxide, we have to switch on to new energy storage systems. It is other than our conventional energy sources such as petroleum and diesel. In this context, supercapacitors can be used. And these supercapacitors can be used in applications requiring a rapid charge discharge cycles in automobiles, buses, trains, elevators, etc. And I think these supercapacitors is eco-friendly and will replace our conventional energy sources in a short period of time. So today, September 16, being the World Ozone Day, known as the International Day for the Preservation of Ozone Layer, we have an apt person, Dr. Liju Manchikal, postdoctoral research associate, University of Glasgow, UK, with us to share his more than 6 years of postdoctoral experience in the field of supercapacitors with us. I think the session will motivate the student and help them to understand more about the new energy system. And I would like to express my sincere gratitude to Dr. Liju Manchikal, sir, for spending his valuable, precious time with us. Thank you, sir, being with us for 1.5 time.
Thank you so much.
Okay. Thank you.
Can I start now?
Sir, next is inaugural address by Anand Kumar, sir.
Okay.
Now I invite Dr. VM Anand Kumar, sir, principal of our college, for the inaugural address.
Thank you. Am I audible?
Yes, sir.
Yes, sir.
Thank you. Respected resource person, Dr. Libu Manchikal, University of Glasgow, United Kingdom. Dr. Vijini BR, head of the department, and internal quality assurance cell, Shama Pillai, and convener of the science club, Dr. Manju MJ, and my teachers and students. So today is celebrated as the World Ozone Day on September 16th. It signifies the all-out efforts by scientists, technocrats, industrialists, and common people to mitigate a problem that would have resulted in the vanishing of all living species from our Mother Earth. The theme this year is the Montreal Protocol, Keeping as Our Food and Vaccines Cool. This is the title of the for 2021 the title for this day celebration. So in 1987, the countries in the world united to sign the Montreal Protocol on substances that deplete ozone layer. So I'm happy that our department, the physics department of the Veluthambi Memorial NSS College, is commemorating this day by conducting an international webinar. I am deeply indebted to the resource person, Dr. Libu Manchikal, for giving some time of his busy schedule to address our students. Thank you very much. Consider this webinar as inaugurated. Thank you.
Thank you so much. So I'm going to share my presentation.
Libu, just 2 felicitations to you.
Oh, okay.
Thank you, sir. Then I would like to welcome Ms. Shama Pillai, IQAC convener, for the felicitation.
Good afternoon and good morning for the resource person. Am I audible?
Yes.
Yes.
Thank you. Respected Principal, Dr. Arun Kumar sir, our most esteemed guest speaker, Dr. Libu Manchikal, University of Glasgow, United Kingdom. Head of the Department of Physics, Dr. Vijini. Webinar Coordinator, Mr. Satish R. Science Club Convener, Ms. Manju. My dear colleagues, students, research scholars from our institution and from other institutions as well. Today, it's indeed a privilege and an honor to conduct a international webinar based on a very pertinent topic, supercapacitors. The topic is relevant in the sense that as technology is advancing with each day, we get to adapt to these technologies through various gadgets, through various other technical, either through the hardware thing or to the software thing. Now, I'm not an expert in science, or neither I'm just let's say a curious learner of science. Now, today for VTM NSS College, this is indeed a great opportunity for the Department of Physics to conduct this international webinar. And I hope this webinar will open vistas of learning, research potential, and other sources, or let's say knowledge sources, through which you can research, analyze, and learn the many of the unexplored sections that is still out there. At the very outset, I felicitate the Department of Physics for organizing such an event. I felicitate our esteemed chief guest, Dr. Libu Manickal, for taking his precious time to be with us today here and opening us a new. Some you might have heard of the topic, but let's see a different version, a different insight into it. And for our ever-inspiring principal, sir, who is always the guiding light for all the programs that we organize and conduct. All dears to colleagues and students for participating in this webinar wholeheartedly. Let us learn, let us know together. Thank you.
Thank you, ma'am. Then I would like to welcome Ms. Manju MJ, convener of Science Club, for the felicitation.
Ma'am, I think you are mute.
Hello. Am I audible?
Yes, ma'am.
Can you hear me? Anyone?
Yes.
Yes,
Yes,
ma'am.
please.
Yes, ma'am.
Hello.
Ma'am, you are audible. No.
Anyone? Can you hear me? Yeah, okay. Good afternoon, everyone. Respected Principal, Dr. VM Anandakumar, sir, IQAC Convener Shama Teacher, Resource Person Dr. Libu Manickal, Postdoctoral Research Associate, University of Glasgow, then Convener of today's webinar, Sadi sir, Dr. Bijini BR, HOD, Department of Physics, Dr. Praveen VN, Department of Physics, my fellow colleagues, and my dear students. This webinar is organized to celebrate Ozone Day 2021. Sadi sir has found an apt person for this job. Dr. Libu Manickal, our resource person, has developed numerous electronic systems for various applications, and he has got more than 75 international publications and over 3 patents. And what I find curious is his invention of supercapacitor working with sweat as the electrolyte. Like student community, we teachers are also eagerly waiting to hear Dr. Libu sir. On behalf of Science Club, I facilitate Physics Department and IQAC to organize this wonderful session. Over to you, Reshma.
Thank you, ma'am. This concludes the inaugural section. Thanks to all the dignitaries who attend the section. Now we move to the webinar, that is the presentation on supercapacitors by our resource person. Over to Mr. Sadish to introduce the speaker.
Okay, just a short introduction about the speaker. Dr. Libu Manickal received his BSc and MSc degree in physics from Calicut University and Mahatma Gandhi University in the year 2006 and 2008 respectively. He obtained his PhD degree in electronic engineering from Institute of Electron Technology, Poland in the year 2015 with a Marie Curie Fellowship. From 2009 to 2012, he was at CMET as a project staff where we met and we came to know each other. After completing PhD from 2015 to 16 for 1 year, he worked as a postdoctoral researcher in the same institute, ITE. In 2016, he joined as in University of Glasgow, UK, as a Marie Curie experienced researcher, and later he is working as a research assistant in EPSRC project until 2018. Since 2018, he is a research associate in the same university. He also has worked as a role of a project scientist, scientific project manager in Marie Curie ITN project IQAC. He has co-authored or authored more than 60 plus articles in high-impact journals, including Advanced Material, Progress in Material Science, Advanced Science, Nano Energy, Biosensors and Bioelectronics, ACS Applied Material Science, etc. He has submitted 3 patents, of which 2 of them are related to supercapacitors: sweat-based textile supercapacitors and flexible graphite composite supercapacitors. Libu has extensive experience in Marie Curie projects in the early, as role as early career researcher during his PhD, and as experienced researcher in postdoc times. Dr. Libu carved his space for himself in the field of advanced energy and electrochemical sensing research through several new innovations such as thick pH sensors, stretchable pH sensors, textile supercapacitors operating with sweat as an electrolyte, flexible graphite polyurethane composite based supercapacitors for prosthetic or robotic application. He has filed a patent on it. Fully flexible self-powered sensors using graphene form-based supercapacitors. Dr. Libu's research achievement has been recognized by several credible agencies. Some of them are: he is shortlisted on important awards such as European Commission for Marie Curie Awards as Promising Research Talent category and Outstanding Young Scientist Scholarship Award from the Polish Ministry of Higher Education. Recently, BBC Science Focus magazine selected sweat-based supercapacitors as the second work for Future Technology 22 Ideas to Change the World in 2020. In 2018, work on graphene-based supercapacitors received Electra Award for the Best UK University Research category. He has led several collaborative funding projects from Royal Academy of Engineering seed funding project in collaboration with partners from Glasgow, India, and South Africa. He is also co-investigator of many other projects related to sensors of water quality monitoring. We are lucky as VTM NSS College Department of Physics is lucky to have a resource person, and looking forward to spending your talk, eagerly waiting. Thank you. You can carry on, Philip.
Yeah. Thank you so much, Sadish. I'm so happy today to present with you. We met in 2009. Sadish was my senior in CMET. After that, we made a very good relation, and I'm very happy you invited me and the Department of Physics and all teachers, principal, all who presented here. Can you see my presentation?
No, I think. No, I think. No.
Can you see now?
Not yet. I will click the present screen window.
Yeah, I done.
Can you do it once again? Like it's not.
No.
No. Okay. You can present the entire screen for.
1 minute. Can you see now?
Yeah, it's coming.
Can you see?
Yes.
Okay. Okay, before going to a detailed presentation on my work, I'm currently working as a scientific project manager of one of the Marie Curie ITN project. We have 10 partners around Europe. From UK, University of Glasgow is leading that project, and then we have partners from UK, other institute like Edinburgh University, Exeter University, and partners from Ireland, Germany, Serbia, many Austria, Poland. Like almost 15 PhD students are working in our project. In this project, we are mainly working towards as advanced sensing technology for water quality monitoring, developing new sensors like electrochemical or physical sensors like pressure, temperature sensors for underwater robotic application. Especially, we are attaching our sensors in underwater robots and monitoring in a wide area, in a remote quality monitoring of water quality monitoring. So this is the major project. If you would like to see more about our work details, you can visit our website aquasense.itn.com. Here you can find our more details of the project. And if you want to see a summary of the work, what we are doing, and what is water quality monitoring in related to advanced technology, we recently published a review article in this area, which can be found in this IEEE Internet of Things channel. Related to my work, I started my PhD. I completed, as Sadish said, I did my physics bachelor and master degree in India. Degree in Malabar Christian College, Calicut, and master degree in St. Stephen College, Udavur. And then I worked in CMET Thrissur. After that, from 2012 onwards, I am mainly working in electrochemical sensors. My PhD is mainly on electrochemical technology. So if any master degree students or bachelor degree students are here, this may be a wonderful topic for you. If you want to do some research on or PhD research in this area, there are plenty of room you can play here in electrochemical technology, especially related to sensors. I developed some of the potentiometric sensors, like what for normally, glass-based sensors are currently available for pH monitoring in a wide application. But the problem of glass is it may easily break. So replaced the glass issues, we developed a planar thick film based pH sensor, like a potentiometric pH sensor. And one of the crucial issue for here is the reference electrode. We solved that issue, and this is my major PhD work. And then I'm mainly working on here in Glasgow University, electrochemical sensors and energy storage, like mainly wearable based energy storage devices. Here you can see a summary of my PhD work, where I started with a rigid pH sensor and then moved towards flexible version of the pH sensor, and finally a stretchable one. And recently, last 2 years back, I developed a cloth-based in a wearable application. You can attach it in our textiles. So the main idea behind this work is to utilize a biocompatible or a sustainable material, replace with other toxic material to make sensors and electrochemical energy storage devices. So when we're talking about electrochemical energy storage devices, one of the, in batteries, nowadays we are using battery for a different application. One of the major application is in wearable systems. So my topic is mainly focused on wearable energy storage devices, like what are the different options for a wearable technology in energy, how the energy plays a crucial role in wearable systems. You know that now, especially when COVID came, the focus more towards related to personalized healthcare monitoring, like wearable medical devices. Many of us are diabetic people, so we need to monitor our health status, like glucose or many other parameters. So there are many work going in the field of sweat monitoring sensors in this aspect. And also there are many work related to physical sensors like a temperature sensor. We are checking our body temperature, pulse rate monitoring sensors. And also if you have all these sensors like physical sensors, sweat monitoring sensors, you can see here, these are one of the reported work from the US. They made a multi-sensor for a sweat monitoring application. And then this is one of our work. Previously, we developed a wearable pH sensor for exercise like sweat monitoring, sweat pH value monitoring, especially for understanding the skin health. And then like a physical sensors for there is an prosthesis. If a person lost their hand or leg, they are replacing with a prosthetic hand or prosthetic leg. But to function like a similar like our human hand, we need to functionalize that a plastic based or a metal based hand into a sensitive feedback. So but all these aspects, we need sensors like various physical sensors, electrochemical or biosensors. In addition with the sensors, to operate those sensors, we need electronic components and like transistors or various resistors. And also we need a communication system. For example, here in the central figure, you can see that you can monitor your sweat level through your mobile phone. When you are going for a running, you can watch your glucose level or a body temperature level through your mobile phone, and then this data can be transferred to a doctor to further checking. But for that, you need an antenna or a communication system. For all these devices or all these components, you need a power source, like a energy source. This could be a battery, or recently there are many work on nano generators like a piezoelectric nano generator. You can see here there are different type of energy harvesting technology, chemical energy harvesting, thermal energy like a fuel cells, and also mechanical energy like a triboelectric energy generators. When you are due to friction when energy generating, it's called triboelectric. And also electromagnetic and a piezoelectric, like when you applied a pressure in a piezoelectric crystal, it generates an electricity. To use those energy generator to apply for a sensor to operate. And also there are various options like light energy, like you know that solar cells. But all this energy generator, to fully functionalize, you need energy storage. There are various type of lithium batteries are there, and also supercapacitors. In addition to that, there are like a self-powered e-skin. When a sensor or an energy generator itself working as a sensor, we call it as a self-powered electronic sensors or a e-skin application. There are different type of energy storage system or energy generators. When we talk about this type of energy generators or energy storage, and in a human or in a wearable application, there are two categories. One is non-sweat based energy devices, and another is sweat based energy devices, like a solar cell or a piezoelectric nano generators. These all are mechanical or light based work, and also batteries and supercapacitors, in which there are in normal battery, you know that there are two type of electrodes is there, anode and cathode. And then these materials may be a toxic material and an electrolyte like an acidic or alkaline electrolyte are there. And then supercapacitor has similar way. So these are non-sweat based energy generators for a wearable application. But recently, last 10 years, the major work is in focusing towards how in wearable application our human sweat can be used as one of the component to operate an energy system. Like there are biofuel cells in US, the Professor Joseph Wang group, they are doing major work on this area, like energy generating use biofuel cells. And then there are human sweat contain different compound of electrolyte, and I will explain you that in later. Those electrolyte used for operating batteries and supercapacitors. You can see here, when you consider a human sweat, you know that our sweat is one of the major component, major part in our body. It's like a human body waste. But that waste, if you can properly utilize that will be a fantastic output. You can see here that in a human sweat contain different components, like sodium is one of the major component, Na+, and then potassium is there, calcium is there, magnesium is there, and also chloride in anions. There are chloride, lactate, bicarbonate, sulfate, and many other ammonia, ethanol, heavy metals. Many chemicals are present in our human sweat. These sweats are, or a human sweat, are there are investigation going on in the field of how human sweat can be related to our blood glucose level, like a sugar, like a blood. For example, nowadays we are doing for a blood diabetic level monitoring, we are taking the blood, and instead of that blood, if you use a sweat as an electrolyte, as a liquid, these works are going on in this area, and also saliva or tear, human tear also can be utilized for these applications. These are a summary of different type of sweat analytes, as you can see here, and sweat-based multi-sensors, and then an energy devices like a biofuel cells, and then a communication system. Then there will be a question, many people may not sweat. So in such application, there are ionotophoresis method, where you can extract your human sweat and then utilize for applications. This is a general concept, like how a human sweat can be used for a energy application in a human body, like a generating sweat, and then from energy you can generate from this, and then that human sweat can be used for a energy storage application, and then a sensors to operate. This is just a summary I want to share with you. In energy generators, I'm not going to detailed explain with you what are the different progress in this area from 2013 to 2020. So if you want to know more about this work, you can visit our new review paper. So our topic today is mainly, I'm planning to discuss with you supercapacitors. Why supercapacitor? In energy storage, when we consider as an energy storage, we are mainly aware about batteries. So one of the best thing to operate any devices, battery is one of the key component. So there are different type of battery. You can see here, the major advantage of battery is that it's very high energy density. And so if it is a very high energy density, for you to operate any devices, for example in mobile or in a sensors, for a long-term operation, battery is one of the best component because of its energy density. But you need to charge fully charge a battery, you need 1 or 2 hours or 3 hours in a fully charging. Then when you consider energy density and power density means a quick delivery of a power. Capacitor are one of the most important component. You know that we are using capacitor we developed for means in electronics applications. But capacitors have a limitation to store the energy because of its the electrode configuration. To improve the capacitance farad, a normal capacitor, to improve the capacitance, you need a large size of dielectric area. To overcome that issue, there are work going on reported in supercapacitors. Supercapacitors as rised in between battery and a capacitor, which have high power density and comparable energy density, but not with the comparable, not high energy density like batteries. But the major advantage of supercapacitors are you can charge a supercapacitor within a seconds of time, and you can deliver a power. For example, if you want to accelerate in a bus or in an electric vehicle, if you want to accelerate, in acceleration you need a quick power delivery. In such application, if you take that power from the battery, you drain the battery very fast. But you need to, like a camera shutter, or in many applications, when you need to deliver a quick power, in such system, a huge amount of power you can store in a supercapacitor and you can deliver in a short interval of time, because of its electrode configuration. So there is work going on. How can we increase the energy density of a supercapacitor to reach battery level? Then you can imagine that you can charge in a battery. If you using a battery, a supercapacitor in our mobile phone, you can charge in a 10 minute or less than 1 minute, and then you can use for a long time application. That is the ambition, but still work is going on in that area, how to improve the energy density of a supercapacitors. This is just a basic. What is supercapacitor? If any master degree students or any PhD students beginning, if they want to develop a supercapacitor, I presented this in many other presentation previous conferences also, but still again I am continuing, because if you are interested to see how to develop a supercapacitors, basically in a supercapacitor you have two electrodes, and in between two electrodes you have an electrolyte. Normal, like in our capacitor, in a capacitor we have a two electrode, in between there is a dielectric. Instead of dielectric, here electrochemical double layer like a liquid electrolyte is as function as a dielectric. And then to overcome the shortening, we are using a separator. So there are two electrode, and in between there is a electrolyte. And to improve the performances of supercapacitor, in this two electrode we are using a different type of material. So when we consider to fabricate a supercapacitor, you first need a substrate. Sadish, can you hear me?
Yes, yes.
Okay. If any missing, please send a message, okay? If there is any problem. Okay, you need a substrate. Substrate can be any material you can choose. For example, if you want to for a wearable application or a flexible application, the best substrate are PVC, like a polyvinyl chloride, a plastic substrate, or a textile. You can use your own cloth also to fabricate a supercapacitor. Okay, so you have a substrate. Then what you do that on the top of substrate, we need a highly conductive material. It's called as a current collector. So for a current collector, you know, aluminum sheet are widely available in our place now for packaging or many other application. Or there are graphene film, or gold film is there, or copper sheet we are using in our laboratory, copper foils. So on the top of this textiles, you can deposit your current collector. In any method you can use, like a bonding method or a screen printing or a dip coating. You can convert your substrate to a conductive substrate. Like on the top of that, you deposited your current collector. And then depending on type of supercapacitors. Supercapacitors we can classify it as mainly three type. The first one is electrochemical double layer supercapacitor. In electrochemical double layer supercapacitor, we fabricate mainly using a graphene or a conductive material, where electrochemical double layer formation. There is no like a electrostatic interaction. When you applied a voltage from the electrolyte, positive or negative ions, depending on the type of the polarity of the electrode, positive or negative ion attracting towards the electrode. There is no electrochemical reaction. Such type of supercapacitors we called as a electrochemical double layer supercapacitor. The advantage of electrochemical double layer supercapacitor is that even though there is no electrochemical reaction, then the lifetime of such supercapacitors are almost 10⁶ cycles. So it's a long life cycle devices. But if you need a high energy density, then of course there need to be an electrochemical reaction like a battery. So in such type, there are different type of metal oxide or polymers or a different type of material we are using. So if you want to make a simple supercapacitor, you have a substrate, current collector, and then on the top of that, you can see carbon or a graphene. Even your graphite pencil, your normal pencil, we can use as a active electrode because it's conductive, not fully conductive, but you can tune that into conductive. And then if you need to further improve your performance, you can use different type of metal oxide like manganese oxide or a ruthenium oxide, zinc oxide. There are many work going on in this area, or in a conductive polymers. And then you need an electrolyte. See, you can use acidic electrolyte or alkaline electrolyte or organic if you need to. This electrolyte fully depending on your operating potential. Because for example, if you are taking water-based electrolyte like alkaline or sodium chloride or a KCl-based electrolyte, you know water dissociation temperature means almost the potential is 1.3 volt. So maximum voltage you can operate in approximately in 1 volt to get a fully operation. But if you need high operating voltage devices like a 2.5 volt or a 3 volt, you need an organic type of electrolyte or a different type of electrolyte. So depending on type of your application, you can choose your electrolyte. And then you need a separator. So you have such a two type of devices. In that two type of devices, you filled with a electrolyte in between. On first you use a current separator. Okay, that separator you can use polypropylene film or a polyester cellulose blend. I mainly use the polyester cellulose blend. Like many material you can use as a separator. So two electrodes separate with a separator, and then you drop an electrolyte. Then finally you can make a packaging. And you have two electrodes, you connection with the two electrode outside. So when you applied a potential, what happened is that the electrolyte contain positive or negative ions. Those ions are attracted towards the electrode, and then depending on the type of the polarity. If you applied a positive here, the negative ions from the electrolyte move towards the electrode surface. And based on the electrode type, it may react electrochemical reaction. So this is the basic configuration of a supercapacitor, either flexible or non-flexible. So depending on your application, you can develop anything. And then this is also again very basic. If you want to characterize a supercapacitor, this yellow box, these are the major parameters you are monitoring, like a specific capacitance, operating voltage, and equivalent resistance. And then you can calculate energy density and power density. For this, there are many characterization technique. I'm not going to explain you in detail that because it takes a lot of time, like cyclic voltammetric analysis, electrochemical impedance spectroscopic analysis, and then charging, discharging, galvanostatic charging, discharging analysis. So I would like to explain you some of my work in this area. So when I started initially my work, initially I was developing a wearable pH sensor. But then I found that it's happened in 2016. So I found that to powering that wearable pH sensor, I need to use a bulky battery. So that is not possible. So what I done that I started with a fully flexible self-powered power pack, in which I developed a pH sensor, like a flexible pH sensor you can see here in the first box, and then a graphene foam based supercapacitor, and you can purchase a miniaturized flexible solar cell also. So this is like a package. I integrated everything, and then from the solar cell, when there is a light, energy generating, and those generated energy stored in the supercapacitor and powered to a sensor. Once I stored the energy in a supercapacitor, almost 24 hours to power a device, to power a pH sensor, I can store almost 24 hours that energy. So in the daytime you can store, and in the night you can utilize for monitoring your pH level of skin or a sweat. So this is the first work, and then I will explain you the other work also, what I done in major 3 type of supercapacitor, in which different type of electrolyte like a sweat also. So this is the major topic I'm going to present today. So as I mentioned you beginning, how supercapacitor can be fabricated. Similar way, I initially started with a graphene foam based supercapacitor. Why I used the graphene foam? You know that in graphene itself or a carbon, there are different variety, like a carbon or graphite, carbon nanotube is there, and graphene is there, and graphene foams are also there. The advantage of graphene foam is it is like a 3D structure. So there are huge amount of porosity. In a supercapacitor, we need a porous material, highly conductive porous material, to react the electrolyte in a more surface area, like a surface to volume ratio to react more. So initially I started with a flexible substrate, and then a graphene sheet act as a current collector, and then I applied a silver material because I need to bond. The graphene foam is like a, you can see here in the SEM, is called a SEM image. That graphene foam I attached on the top of the silver, and then like a 2 electrode configuration I bonded with what you call a separator. So the major advantage, so you see, in a normal capacitor, as I mentioned, dielectric is mainly important. So in a supercapacitor, you have a current collector or an active material. On the top of that, you are applying an electrolyte. If your electrolyte is fully distributed, then like a hydrophobicity or a hydrophilicity. If it is an hydrophobic, when you drop an electrolyte, it's look like a bubble there. So not distributing well. So in such application, such a device will not work properly. So you need a hydrophilic material, like you can see here. When I drop an electrolyte, you see I'm dropping an electrolyte here. On the this is the in the bottom you can see a graphene form there. When I 1 minute, sorry. Yeah, when I drop the electrolyte, it is fully distributed. So if the electrolyte is fully distributed, that means that your electrodes are fully wet. Then when you apply the potential, the all electrode will work properly. So you can see here, this is the device I fabricated, flexible device. And in the second figure, you can see here, when I applied a potential, due to this graphene form, and there is like a 3D structure. In internal of the bulk of the material, the ions are distributed, and in a ions are fully distributed around the material. And then I used here a phosphoric acid as an electrolyte. Of course, the question will come, phosphoric acid may affect our human body. So I did a packaging that time. I used initially acidic electrolyte. And then I characterized the material like a cyclic voltammetric analysis. Maybe if you are a bachelor degree students or master degree student, it may be difficult, but maybe you are starting your master degree project, it may be very useful for you to learn about cyclic voltammetric analysis as a master degree project, how to characterize a material. So, and then an impedance spectroscopic analysis I used because we need to measure the electrode resistance and how much capacitance it can store. So I used electrochemical impedance spectroscopic analysis. Here you can see I measured my device. It's like a 3 centimeter device, 3 centimeter square area, 1.2 farad capacitance. If you need a 1 farad in a normal capacitor, you can imagine how much area, how much large size you need. So in that aspect, a supercapacitor in a very small area, you can obtain very high capacitance. And then I measured the device like a, GCD means galvanostatic charging discharging analysis. We normally in our mobile phone, we are charging our phone in a fully charged, like a 3 volt or a 4.2 volt. Here I used 0.8 volt. And once we fully charge, then we discharging through our operation, normal operation. This is like that. When you charge your device fully, and then it is normal discharging to measure the fully performance of our device. And I calculated the how much energy density my device can provide, and then life cycle. Normal battery maximum will work like a 3,000 cycle or 3,000 cycle, depends on the material, because it may react in the electrochemical reaction. But in my device, I got 25,000 cycles of operation, and this is the last 10 cycle of 25,000. So you can see that it's still fully working in after 25,000 cycle itself. And then finally, I integrated the device, like you can see here, and I measured solar cell property also. And then I applied for a pH sensor. You can see in the bottom figure where I used a pH sensor to operate using by the graphene form based supercapacitor. This work I published in Nano Energy, and you can see if you need more details, you can find from here. See, you can see here there is a sensor inside the beaker, and here in the table you can see that the green color there is a supercapacitor, and supercapacitor powering the sensor and operating, that you can see here. And later the previous version of supercapacitor have a limited operating potential. Sorry. If I want to operate, you know that in a toys car, there is a battery. That maybe we need a 2 type of battery, like a 3 volt battery to operate. Or there is a motor in many devices. In those motors, mainly you need 2.5 volt. Or if you need an LED to operate, you need at least 1.5 volt and 3 milliampere current. So you need when we need to operate in a high power devices, in a wearable application itself, you need at least minimum 1.5 volt or above 1.5 volt and with a high current. So my second work, I developed a new composite material. This I filed a patent in UK patent this. I prepared a new composite material which can be used for operating in a high voltage application. And again, a similar way, I fabricate the device. I have a flexible substrate and then current collector. And this is that black color is that the same image you can see here, GS and then PU. This one is the graphite new composite I prepared. So the major advantage of this material is that you can see clearly, you can see here, there is a bubble on the top of it. When you use only for a graphene sheet in a normal device, it's look like a bubble when you drop the electrolyte. But when I used my new material composite, the electrolyte is fully distributed and it has a very good surface area to react the electrochemical reaction. And it's like again a graphene based material, the graphene polyurethane composite I used. And when I applied again I used here a phosphoric acid. When I applied electrode, the phosphoric acid contains many positive and negative ions. These are attracted towards the graphene sheet. And here, when I compare the devices, the graphene polyurethane based supercapacitor, I'm not giving you a detailed explanation, shows a better performance in terms of capacitance wise, and also high energy density as compared to the normal supercapacitor. You can see here in operating in a milliwatt range, the device. And when we need to develop a supercapacitor for a flexible or a wearable application, flexibility of the you can imagine that our normal battery we using our phone or in a toy car is not flexible. It is like a rigid one. But in a wearable system, you need a flexibility is one of the important factors because in a curved surface. So what I done that I developed the device and I carried out a flexibility study. You can see here I attached the device on a too rigid like a motor, and when the motor is moving and this device is bending, you can see here the device bended. So let's imagine a battery which is bended. So and then it is operating fully, and also in a curved surface like in a body or in any curved surface, you can easily attach. It is like a static bending or a dynamic bending. When you are moving and running, and when you need a dynamic bending, you can use this type of supercapacitor. And then you can see here I used that two such a supercapacitors and a solar cell, and then I used in a solar cell for energy generation, and then this energy I stored in the supercapacitor, and then I connected to this 84 LED. I connected to 84 LED here and to power that device. So one LED required 1.5 volt, and I used a proper energy management system, and then to operate the device. And then when you have a motors, you see here a motor required a 2.5 volt. Then I used my supercapacitor wrap around, means it's wrapped in a 3D printed cube, this yellow one, and then I powered the supercapacitor, charged it, then this supercapacitor then power deliver it to a motor to operate. So you can see here. See, so when you want to operate a motor, when you need to deliver a quick power to operate a motor, these supercapacitors are very useful. And then finally, what I did that in a human hand, if you have a prosthetic hand, your fingers, it's like a plastic one. This is developed in one of my colleagues, this prosthetic hand. So these fingers containing motors. Okay, so if you want to hold an object, this finger need to be power. So in such a power, if you need to deliver a power, you need a bulky battery. So initially we developed using this again a bulky, you can see here solar cell. We can replace this is like a proof of concept. I integrated a supercapacitor on the hand and then powered using a solar cell to operate these motors. You can see here like in a wristband, you can operate like a wristband to power the devices and for various applications. In all these devices, I already told you that I used a phosphoric acid. But again, if there is an accident and if your substrate, if your packaging broken, then the phosphoric acid may leak and it affect on your body. It may related, it may easily skin may got damage. This is similar case of battery also. in a wearable application. So in such a case, you need to replace the acidic electrolyte. So my next work, I used human sweat as an electrolyte. So previously I developed a pH sensor in which I used human sweat. I was using for monitoring the pH level. Then I noticed that in that when I worked on the pH sensor, I noticed that there are a lot of positive and negative ions like sodium chloride. In a supercapacitor, we need a sodium chloride as an electrolyte. So why not we can use human sweat directly as an electrolyte? So, but in such cases, the device need to be more matching with our sweat. So what I done that I used a normal cloth like a cellulose cloth to develop a supercapacitor, and the normal cloth is not conductive. In supercapacitor, as I mentioned to you beginning, you need a conductive material. So I drop normally in a simple method like a drop method. I convert that cloth into a conductive cloth like a P.PSS, and then when I convert that into a conductive cloth, I attach the electrode here, and such a two electrode. You can see here a normal cloth coated with the P.PSS. This is in each fibers of the cloth, the P.PSS is coating. And then I used a separator again, like a two type of electrode using cloth, and in between I used another cloth as a separator, and then wrap around this electrode and attach it on a human body. So what happened is that due to P.PSS, there are two type of reaction can happen. One is it is a highly conductive material, so electrochemical double layer, and due to this conjugated polymer in a bulk of the material, there is a redox reaction also when human sweat is reacting on the conductive cloth. You can see here in a human sweat contains sodium ion, water, normal water, and chloride ion. This is fully distributed. And here the device which I fabricated, you can see is a 1 centimeter, very small device. And then initially I prepared a human sweat equivalent electrolyte in my laboratory. We can develop by using chemicals. And initially I prepared the human sweat equivalent electrolyte. Then I compared this with when our normal human sweat. When we run during running, we collected the human sweat and done the experiment. And when I compare this with the chemical and with the human sweat, I found that almost same capacitance like a 7 farad gram I observed for both. And this is I measured using an electrochemical measurement. And again, we sweat in a different level. Now I'm currently living here in UK. Here sweating is very difficult because of the climate and weather. But in India, we may sweat a lot. But also, it depends on the physiological status of a human body. Some person may sweat very low, some may be a large amount. So the volume of sweat may be different. So I fixed a device size like a 3 centimeter square device, and then I used a different amount of volume of sweat to compare the performances. So depending on your size of the electrode, this sweat, the electrode can be performed in different way. I observed that that's 3 centimeter square, when you have a fully sweat, it gives me a better performance, like a very good electrochemical reaction, like a cyclic voltammetric and almost rectangle shape, and then a very high capacitance also. Again, in a cloth, when you sweat and you are in a cloth, the sweat may evaporate very fast. So what I done that I collected the sweat, human sweat, and then it is wetted. Initially, I did a measurement, and you can see here in the initial cycle what is the performance, and I compare. I done a long time study, like a 4,000 cycle. I measured almost, and then 4,000 cycle. After 4,000 cycle, I noted that the performance is reducing. Then I broken the device and I check what happened to my device. Then I found that the sweat is fully evaporated and the material got some damages. So here I used the P.PSS as a normal conductive material. So if you are planning to do a research on this supercapacitor, I must say that if you found a new good composite material, there is a lot of huge opportunity you can play here. The problem of P.PSS is that it's a very highly conductive, but when you react with the water, it easily disintegrates and it reduces your performance. So if instead of period PSS, if you can coat another material, a good composite material, which can absorb sweat and which can perform very well in sweat, then your performance may, instead of 4,000 cycle, you can increase more than that. Because what I done that after 4,000 cycle, I again dropped the sweat and I saw the device is again performing. But if the material is not disintegrate, I may get a good performance again. So I done that comparison also. So you have a better chance if you want to do here. There are my colleagues also done my supporting here. So here you can see one of my colleague, he attached the device on his chest. You can see here in the, when he during exercise, he is this white, that circular one we use a cello tape, and then attached on the body, and then when we're doing the running, you can see here the device is working very well when we start. So in another experiment, what we did that this is my friend Sadish know very well him, Abhilash. What we done that you can see Abhilash is here. So he attached the device on his body, directly on the body. And when he started running, initially he was not sweating. So the device working was very poor. But once after sometimes when he started sweating, we noted that the device get a very good performance, like a stable performances. So depending on the amount of sweat, it may perfect well. So what we used as a device is that like a salinity monitoring, sodium level monitoring. You know, monitoring of sodium is very important for a human health monitoring. So we powered the supercapacitor for used supercapacitor for powering the sensor. Still, we used a solar cell. You can replace solar cell with a biofuel cells or any other energy generator, and we need to find a more good method to operate this. These are the comparison study of these three work, and I'm very happy. The first work, graphene foam in University of UK research, one of the industrial award. It got a best UK university research category award, and then another supercapacitor we got a international to get a commercial application we are checking, and then another work got a very good notification in BBC Science Focus magazine also. Again, we are now today's World Ozone Day, so WHO also talking about sustainable environment. So when we talking about a sustainable environment, energy storage device have a crucial parameter. In energy storage devices, previously I used a polyester or a polymer based material. So such a material, again, we are using, maybe we creating pollution or we are creating any other issues. So there is an option. Then later I used a textile as a substrate. So why not we can fully fabricate textile based devices? Like what I done that I have a work in collaboration with India, like a circular economy, related to circular economy, where jute fiber, jute is one of most commonly available in our place. We are using for carrying rice and sack, we are using that. So jute contain a very good large amount of cellulose material. So we used the jute bag for packaging our food packaging, and you know that there is a in a food. Many times we saw that in a rice bag it's got a mold and everything, and it lost. So we need to store in a rice or any other fruit in a good condition bag. But for that, you need to monitor the status of the environment, like a humidity or a temperature, all this. You need sensors. So what I done that I used a jute fiber to develop an energy storage device. So here you can see that a jute fiber, like a circular fiber, you know that is a plenty of fibers we available in our Kerala. So we can use that to fabricate an energy storage device on an electronic product. The advantage is that we are using a biocompatible material, biodegradable material. After you utilized your your application, you can easily throw to the environment. It will easily disintegrate. So what we done that we fabricated a jute fiber based supercapacitor, and then to power a temperature sensor and a humidity sensor. Here you can see a bag I attached with a sensor and a solar cell. Solar cell I again used for to charge the supercapacitor to power the device. And this is recently published in this year, published in Advanced Sustainable System Journal, in where we notified about a sustainable goal like a use of biocompatible material. Again, there is plenty of room, as I mentioned to you, in a wearable application itself. There are different type of sensors and different type of electronics component like a pH or analog to digital converter, microcontroller, and wearable sensors also, or a human machine interaction also. This all required power. The next few years, we are planning to replace with a battery with a more biocompatible energy storage devices. Still, we are not reaching in that level to fully replace the battery, because a huge amount of power required. So you have a lot of space to work here to develop a new energy storage devices and energy generator to fully operate these type of devices. Especially currently, we are looking more in a wearable medical devices for a self-health management. Thanks to my funding agencies like EPSRC and European Union Marie Curie, because currently I'm working in that, and my all colleagues who supported me and the work. And this is just a if any one of you are just completing your master degree, if you want to do a PhD in abroad in Marie Curie program, because I completed and I worked in CMET, and I was a long time searching a PhD, a good PhD opportunity, fellowship opportunity. So one of the best fellowship if you want to explore your PhD career is Marie Curie program. So if you are planning, any of you are planning to do, please think about your master degree is very important, and your CV. So you need a very good score, an excellent project. Please think about not to finish your master degree project in the last 1 month or 2 months. If you carried out a very good project, if you get a chance to publish a paper in your master degree project and a very good presentation like a oral, like in a conferences or webinars, and if you got an award related to that master degree project, that will be very fantastic you to get a Marie Curie fellowship. You don't need any other things, because if you just come with a master degree, you know that you are competing with a huge amount of people to get such a fellowship. So if you want to distinguish between them, and if you want to be in the prime position of the interview, you need to make your CV very good. And check, there are many opportunities you can see. Apply. Sadish know very well, maybe he can explain to your student how I got my fellowship. I checked a long time to get a Marie Curie fellowship. If you got a Marie Curie fellowship, it's a 3 years, you can do your PhD. You get a very good training. You can explore different institute. I explore many European countries, many other countries also, and I carried out, stayed in many places for doing my work. And multicultural activity, a very good excellent salary. You can support your family also. You can bring your family. You will get a family allowance for that also. Summer school, workshop, very good food, and team building. So just check various opportunity, but prepare your bachelor degree, master degree in a very good way. If you can start a project in your bachelor degree itself, that will be fantastic. Thank you for your attention. If you have any doubt, please let me know.
The session is open for discussion.
I think I am very fast because of the time restriction. I have another meeting at 11:30. So sorry.
No problem.
if you need any help to apply for a Marie Curie fellowship and everything, the students, I'm talking about the students, if you need any help, you can contact, and Sadish know my contact details. So please check very good opportunities.
Researchers can ask questions.
Hello, sir.
Hello, Vignesh.
Sir.
Yes,
Sir,
yes, Vignesh.
Is there any health issues regarding using this?
Health issues. Vignesh, you asked health issues?
Yes, sir.
No, there is no health issues, because in one of our work, Abhilash is leading, one of my colleagues, we did cytocompatibility test, like a human cell, how when we attach it in a human body, is there any issues? We checked that also, especially that textile based work, and we found that there is no health issue when we are using such a device. But of course, when you use a toxic material or a toxic electrolyte, if it is leakage, that is why I tried to overcome with the phosphoric acid to use more biocompatible material. There is, depending on type of your material, you can avoid this. There is no other health issues.
Okay, thank you, sir. Can I ask one more question?
Yes.
Can we use this wear band to those who can move their arms and legs to help them?
Yeah, that's a fantastic question, Vignesh. This is what I mentioned about the prosthetic. Okay, so the issue is that still we are not reached a supercapacitor. A fully supercapacitor can be used for a prosthetic hand movement, but to operate a sensor or a single motor, you can use this power. We are currently using a bulky battery in a prosthetic hand or a prosthetic leg to operate them. For example, your hand is very sensitive to temperature. If you touch cold, or if you want to take a egg, you need to, know how much pressure you need to use. But in a prosthetic hand, don't know about this, how much pressure you need to use. In such a type of devices, you need a touch sensor, okay, on your hand, on a prosthetic hand. In that touch sensor, to operate that touch sensor, you need a power. So in such application, we can use, but the work is going on. How can we use a full supercapacitor to power the full device, full prosthetic hand? If you found, Vignesh, are you doing master degree or a PhD degree?
No, sir, bachelor degree.
Oh. Bachelor degree. So you can start now itself, Vignesh. It's the best time to start. You can think about there are a lot of group research communities. Sadish know very well. In Trivandrum itself, or I don't know whether you are working in the same college, studying in same college. There are many groups where they are thinking about many materials for fabricating prosthetic hand or a supercapacitors. So think about, there are many design you can use, and how to use a good supercapacitor, how to develop a good supercapacitor which can operate. You need at least 6.5 volt for a full battery. In such a battery, you need to operate, and a huge power you require. So you can slowly start reading about in prosthetic hand, okay, and different prosthetic components are there. There are huge amount of publication you can see in Wiley or in some other journals, advanced electronic material related to prosthetic hand or prosthetic fingers, how they're using power in that fingers and how much power required. And start reading, and then you will start a project. You can discuss with some research group in your places, and think about to develop a good device, okay, of supercapacitor or a prosthetic and or a full device. I came to know that in Kochi and everything, there is a new company maybe soon will start on supercapacitors. So there are a lot of startups also going on. CMET Thrissur also there are very good work in supercapacitors. You can do your master degree project in some places or bachelor degree project. Things start now. Okay, I like your question very much.
More grateful to you.
Still there is not because we are trying to find a good supercapacitor, fully flexible supercapacitor to fully operate these devices. The work is progressing very well in this area. The key factor is operating voltage, miniaturized size, and a good material, high energy storage materials.
Thank you. Thanks.
Okay.
Any more questions?
ആർക്കെങ്കിലും എന്തെങ്കിലും സംശയം ഉണ്ടെങ്കിൽ ചോദിക്കട്ടോ, മടി വിചാരിക്കണ്ട. എനിക്ക് അറിയാവുന്നതാണെങ്കിൽ ഞാൻ പറഞ്ഞു തരാം. Or you can send me an email also if you are shy to ask.
സാർ ഒരു ചോദ്യം കൂടി ചോദിച്ചോട്ടെ?
ചോദിച്ചോളൂ.
സാറിന് ഈ പ്രോജക്റ്റ് ചെയ്യാനുള്ള ഇൻസ്പിറേഷൻ അല്ലെങ്കിൽ അങ്ങനെ തോന്നാൻ കാരണം എന്താണ്?
ഇപ്പം ഇൻസ്പിറേഷൻ പറയുകയാണെങ്കിൽ ഞാൻ PhDക്ക് ഇലക്ട്രോ കെമിക്കൽ സെൻസറിലാണ് വർക്ക് ചെയ്തത്, pH സെൻസറിൽ. അപ്പോൾ ഞാൻ അന്നേരം യൂസ് ചെയ്തിരുന്ന മെറ്റീരിയൽ റുദീനിയം ഓക്സൈഡ് ആയിരുന്നു. അപ്പം ആ റുദീനിയം ഓക്സൈഡ് അതിനെക്കുറിച്ച് കൂടുതൽ പഠിച്ച സമയത്ത് വൺ ഓഫ് ദ ബെസ്റ്റ് മെറ്റീരിയൽ ഫോർ ഇലക്ട്രോ കെമിക്കൽ സെൻസേഴ്സ്. അതുപോലെ തന്നെയാണ് അത് സൂപ്പർ കപ്പാസിറ്റേഴ്സ് ആപ്ലിക്കേഷനും ഒരുപാട് യൂസ് ചെയ്തിരുന്നു. പക്ഷേ അന്ന് എനിക്ക് അതിൻ്റെ ഒരു റെസ്ട്രിക്ഷൻ ഉണ്ടായിരുന്നു. എനിക്ക് കാരണം എൻ്റെ പ്രൊജക്റ്റിൻ്റെ ഡെലിവറബിളും എല്ലാം വെച്ച് അതിൻ്റെ ഒരു റെസ്ട്രിക്ഷൻ ഉണ്ടായിരുന്നു അപ്ലൈ ചെയ്യാൻ വേണ്ടിയിട്ട്. പിന്നെ പോസ്റ്റ് ഡോക്കിന് ജോയിൻ ചെയ്ത സമയത്ത് ഈ വിയറബിൾ സെൻസേഴ്സിലേക്ക് വന്നപ്പം പലപ്പോഴും ഞങ്ങളുടെ വർക്ക് നടന്നിരുന്നത് വിയറബിൾ സെൻസറിൽ തന്നെ അതിനെ ഓപ്പറേറ്റ് ചെയ്യാൻ വേണ്ടിയിട്ട് നമ്മൾ വോൾട്ടേജ് സോഴ്സ് നമ്മുടെ ലാബിൽ കാണാം, വലിയ വോൾട്ടേജ് സോഴ്സ് ആണ്. ഈ വോൾട്ടേജ് സോഴ്സാണ് യൂസ് ചെയ്തുകൊണ്ടിരുന്നത്. അതുപോലെ തന്നെ ബൾക്ക് ആയിട്ടുള്ള ബാറ്ററികളെല്ലാം. അപ്പൊ എന്തുകൊണ്ട് വിയറബിൾ ആപ്ലിക്കേഷൻസിൽ ന്യൂ ടൈപ്പ് ഓഫ് എനർജി സ്റ്റോറേജ് ഡിവൈസസ്, വിയറബിൾ എനർജി സ്റ്റോറേജ് ഡിവൈസ് ചെയ്തുകൂടാന്നുള്ളൊരു ചിന്ത വന്നു. ആ സമയത്ത് ഒരുപാട് വർക്ക് ഈ ഏരിയ നടന്നിട്ടുണ്ട്, നല്ല വർക്ക് നടന്നിട്ടുണ്ട്. ഞാൻ ആദ്യമായിട്ടൊന്നുള്ളത് ചെയ്തിട്ടുള്ളത്, ഇതിലും നല്ല അടിപൊളിയായിട്ട് ചെയ്ത ആൾക്കാരുണ്ട്, നല്ല എക്സ്പീരിയൻസ് റിസർച്ചേഴ്സ് ഉണ്ട്. എങ്ങനെ മെറ്റീരിയലിൽ മാറ്റം വരുത്താം, എങ്ങനെ ഒരു പുതിയ മെറ്റീരിയൽ കൊണ്ടുവരാം എന്നുള്ള ചിന്തയിലാണ് ഈ ഒരു പുതിയ വിയറബിൾ എനർജി സ്റ്റോറേജിലേക്ക് വന്നപ്പോൾ ഈ ടെക്സ്റ്റൈൽ സ്വെറ്റും അതുപോലെ ഗ്രാഫിൻ ഫോം എല്ലാം വന്നിട്ടുള്ളത്. ഞാൻ സ്വെറ്റ് ബേസ്ഡ് സൂപ്പർ കപ്പാസിറ്റർ വർക്ക് വെരി റയർലി ആണ് റിപ്പോർട്ട് ചെയ്തിട്ടുള്ളത്. എനിക്ക് തോന്നുന്നത് ആ ഒരു കോൺഫിഗറേഷനിൽ ദ ഫസ്റ്റ് റിപ്പോർട്ട് വന്നിട്ട് ഞങ്ങളുടെ ഗ്രൂപ്പിൽ നിന്നായിരിക്കും. ആ ഒരു സെറ്റിനെ എങ്ങനെ റീയൂസ് ചെയ്യാന്നുള്ള സെറ്റ് ബേസ്ഡുള്ള എനർജി ജനറേറ്ററെല്ലാം ഒരുപാട് വർക്ക് നടന്നിട്ടുണ്ട്. അപ്പം മെയിൻലി നമ്മുടെ ആപ്ലിക്കേഷൻ ഓറിയന്റഡ് ആണ്. കാരണം ഒരു ഫ്യൂച്ചർ ടെക്നോളജി ഇപ്പം നമുക്കറിയാം, ആപ്പിളിന്റെ വാച്ച് ഉണ്ട്, അങ്ങനെ മെനി ഡിവൈസസ് ആർ യൂസിങ് ടു ചെക്ക് ദ പൾസ് റേറ്റ് മോണിറ്ററിങ്. അതുപോലെ ഡിഫറെന്റ് സ്കിൻ ഡിസീസസ്. ഫ്യൂച്ചറിൽ എന്ത് തന്നെയായാലും നമുക്കൊരു വിയറബിൾ ഡിവൈസസ് ഇംപ്ലാന്റബിളോ അല്ലെങ്കിൽ വിയറബിൾ ഡിവൈസസോ ഇത് രണ്ടും വളരെ അത്യാവശ്യമായിരിക്കും. കാരണം റിമോട്ട് മോണിറ്ററിങ്ങിന് ഇപ്പം നമുക്കൊന്ന് ആലോചിച്ചാൽ മതി. ഇപ്പൊ ഒരു പേഷ്യന്റ് ഒരു ബെഡിൽ കുറേ കാലമായിട്ട് ബെഡ് കിടക്കുന്ന ഒരു പേഷ്യന്റ് ഉണ്ട് അസുഖമായിട്ട്. ഇപ്പൊ അവർക്ക് വൂണ്ട് ഉണ്ടാവാം, മുറിവൊക്കെ കിടന്ന് ചിലപ്പോൾ മുറിയും. നമുക്ക് ഏതെങ്കിലും അസുഖമുള്ള ആൾക്കാരോ വയസ്സായ ആൾക്കാരൊക്കെ, ഏജ് ഡിപ്പെൻഡിങ് ഓൺ ഏജ് ആൾസോ. അപ്പം അത്തരം സ്ഥലങ്ങളിൽ ഒരു വൂണ്ട് ഉണ്ടാകുമ്പം ആ വൂണ്ട് മോണിറ്റർ ചെയ്യണമെങ്കിൽ നമുക്ക് എന്ത് വേണം? സെൻസർ വേണം. കാരണം നമ്മളിപ്പോൾ യൂസ് ചെയ്യുന്നത് എന്താണെന്ന് വെച്ച് കഴിഞ്ഞാൽ ഒരു വൂണ്ട് മോണിറ്ററിങ്ങിന് നമ്മൾ ഹോസ്പിറ്റലിൽ പോയിട്ട് അവിടെ പോയി ഡ്രസ്സ് ചെയ്തിട്ട് അവർ ബാൻഡേജ് ഉണ്ടെങ്കിൽ ആ ബാൻഡേജ് ഓപ്പൺ ചെയ്ത് നോക്കും. അത് ചിലപ്പോൾ കോംപ്ലിക്കേറ്റഡ് ആക്കാം, എസ്പെഷ്യലി ഓൾഡ് പീപ്പിൾ ആകുമ്പോൾ. അപ്പൊ അത്തരം സ്ഥലങ്ങളിൽ നമുക്കൊരു റിമോട്ട് ആയിട്ട് ഒരു വൂണ്ട് മോണിറ്റർ ചെയ്യാൻ പറ്റുമെങ്കിൽ, ലൈക്ക് സ്മാർട്ട് ബാൻഡേജ് ടെക്നോളജി ഇപ്പോൾ വളരെ അഡ്വാൻസ്ഡ് ആണ്. അത്തരം സ്മാർട്ട് ബാൻഡേജ് ഉപയോഗിച്ചിട്ട് നമുക്ക് നമ്മുടെ വിയറബിൾ ആപ്ലിക്കേഷന് നമ്മുടെ ഹെൽത്ത് മോണിറ്റർ ചെയ്യാം. പക്ഷെ അഗെയിൻ ഇവിടെ ഒരു ഇഷ്യൂ പവറാണ്. ബൾക്ക് ബാറ്ററി നമുക്ക് ഉപയോഗിക്കാൻ പറ്റില്ല അത്തരം ആപ്ലിക്കേഷനിൽ. അപ്പം അത്തരം ആപ്ലിക്കേഷനിൽ സ്കിൻ പാച്ച് ലൈക്ക് പാച്ച് ആപ്ലിക്കേഷൻ, സ്കിൻ സെൻസേഴ്സ്, ഹ്യൂമൻ ലൈക്ക് സെക്കൻഡറി സ്കിൻ വേണം നമുക്ക് പറയാം. ഇപ്പൊ നമ്മുടെ ഹ്യൂമൻ സ്കിൻ ഉണ്ട്, അതിന്റെ മുകളിൽ ഒരു സെക്കൻഡറി സ്കിന്ന്, അല്ലെങ്കിൽ ഒരു പ്രോസ്തറ്റിക് ആൾക്ക് അയാളുടെ സ്കിൻ മാറ്റി വെച്ചിട്ട് അവിടെ ഒരു ന്യൂ സ്കിന്ന് നമ്മൾ ചെയ്യുന്നുണ്ട്. അത്തരം സ്കിൻ ആപ്ലിക്കേഷനിൽ ഒരു സെക്കൻഡറി സ്കിൻ ആപ്ലിക്കേഷനിൽ പവർ ഒരു ഇമ്പോർട്ടൻ്റ് ഫാക്ടറാണ്. ഞാനിപ്പം വർക്ക് ചെയ്തുകൊണ്ടിരിക്കുന്നത് തന്നെ എൻ്റെ ഫുള്ളി ഫോക്കസ് അത്തരം ആപ്ലിക്കേഷനിൽ എങ്ങനെ ഒരു ഫുള്ളി വിയറബിൾ എനർജി നമുക്ക് യൂസ് ചെയ്യാൻ പറ്റും എന്നുള്ളതാണ്. ഒരുപാട് സ്ഥലങ്ങളിൽ നമുക്കത് യൂസ് ചെയ്യാം. ഒരുപാട് ഹെൽത്ത് കെയർ ആപ്ലിക്കേഷനിലോ അല്ലെങ്കിൽ സ്പോർട്സ് ആപ്ലിക്കേഷൻ, മിലിറ്ററി ആപ്ലിക്കേഷൻസ്, കമ്മ്യൂണിക്കേഷൻസിന് ഒരുപാട് സ്ഥലത്ത് നമുക്കിതിൻ്റെ യൂസേജ് ഉണ്ട്. ഇവിടെയൊക്കെ ഒരു ക്രിട്ടിക്കൽ ഫാക്ടർ മെറ്റീരിയൽ ആണ്, എങ്ങനെ ന്യൂ മെറ്റീരിയൽ കൊണ്ടുവരിക എന്നുള്ളത്. സോ എൻ്റെ ഡ്രീം അതാണ്, ഒരു ഫുള്ളി ഫങ്ഷണലൈസ്ഡ് ആയിട്ടുള്ള എനർജി ഓട്ടോണമസ് സിസ്റ്റം, സെൻസർ സിസ്റ്റം എന്നുള്ളത്. അപ്പം ഞാൻ ആ ഡ്രീമിലേക്ക് നടന്നുകൊണ്ടിരിക്കുകയാണ്, എത്തിയിട്ടില്ല. നമ്മളിങ്ങനെ ഇപ്പോഴും അതിനെക്കുറിച്ച് പഠിച്ചുകൊണ്ടിരിക്കുകയാണ്.
Thank you so much, sir. Wish you all the best for your dream coming true.
Yeah.
Okay, if there are no more questions, we can move to the next session. Reshma?
Thank you, sir. Hope that all doubts are clear. Once again, thank you, sir, for your valuable words. Now we can move on to the next section. Vote of thanks. I would like to welcome Dr. Praveen VN, Assistant Professor of Physics Department.
Praveen sir. Okay, Praveen sir, maybe he made me not in line, I believe. Okay, vote of thanks. I will deliver the vote of thanks. First of all, I would thank the organized and the supporting staff of my seminar, like the IQAC and Science Club, who gave support for success of this seminar. First of all, to start with, I would thank the presidential address Dr. Bijini presiding, who presided also Dr. Bijini BR, HOD Department of Physics, who welcomed the gathering. And now next is Dr. Anand Kumar VM, Principal, VTM NSS College, who inaugurated the session and gave valuable suggestions for the seminar. And next is all the teachers and participants of the seminar outside VTM NSS who can participate in this talk. And more, I shouldn't forget the resource person who, within the valuable time, who within his valuable amidst the meeting, he came to us to give a nice presentation in a simple manner. I believe there are a lot of works, like what Richard Feynman says, there is a lot of room in the bottom, like that. There is a lot of work in his hand and less time to discuss with us. I wish all the best for his work and let him come to India and contribute to the Indian community. I believe finally let him contribute, make India proud. By his research contribution. One day he will return back, I believe. Finally get into some institutes within India, because he's a from his profile I could find that he is by his sheer hard work he is a good researcher, and I believe that he has made his SWET work well, right? By his works, SWET-based capacitors, and he knows the value of SWET. I thank Dr. Libu for spending his valuable time and making the students and young researchers get valuable ideas, and probably I gave your address also, website address also. Maybe they will contact you by mail you, and some few of them may get good support from you in future, maybe after completing their PG work or something like that. So that's way you can guide different students in future. Maybe this will mutually help you and your the participants who are sitting this seminar. And also I would like to thank my students and my teachers who helped me into organizing this seminar and make this a success. Thank you all. Thank you for the valuable time you spent with me. Thank you, Slibu.
Thank you, Sadish. Thank you all.
Excuse me, Sadish sir, can you hear me?
Yeah, Praveen sir, I just sorry.
I just want to apologize to Dr.
No
Libby,
problem.
sir.
No, sorry.
Sir,
No problem.
no, sir, at the last moment, my phone got hanged up and I ran from door to door to get another one connection. That's
So the same thing happened to me many times.
No problem.
As I was about to switch on my speaker to start my vote of thanks, my phone hanged up.
Okay.
I don't know. Sir, really it was a wonderful talk, sir. And while we were discussing to plan about an webinar like this, the first name Sajay sir suggested was your name only. And he just told us that, sir, please wait for one more day. I want to just get a confirmation. And the next day itself, Sadish sir just told that you are willing to give us a talk. And after reading your profile itself, I found it will be a great talk, and you have not disappointed us, sir. It was really a wonderful talk, and the one thing which I would like to appreciate is the positive feedback you gave to that BSc and MSc students. And most probably in all our talks, we used to hear that people come, they talk, and they go without. But you are not like that. You just express how to get that Curie fellowship, and your talk was really motivated. And I think guys like Vignesh will follow your footsteps, sir.
Thank you.
And
whenever you Sadish know very well.
When you come to India and Kerala, sir, please find time to visit our institution and give us a talk. It will be really wonderful for every one of us, sir.
Sure.
Thank you for spending your valuable time, sir. Thank you.
Thank you.
Okay, thank you.
Bye now, Sadish. Everyone, bye now.
So thank you all for participating in this webinar. You can fill the feedback form and receive your certificate. The feedback form is pasted in the chat box.